Hackers and hackerettes, welcome to a new video in the PortSwigger lab, I guess, saga. In this video, we'll be starting a new learning path, SSRF, and this is a newish topic for me as well. So you'll be going through me, going through with me as I learn this new topic myself. And then we will solve the first lab together, or at least attempt to, because we could very well fail. And I guess just come along for the journey. We're going to be going through the slides until we get our first lab, attempt to solve the lab, and then I'll be just creating another video for the next lab and so on. All right, so let's get started. The very first slide, or I guess page, is an introduction to SSRF. So essentially, SSRF, or server-side request forgery, is a web security vulnerability that allows an attacker to cause the server-side application to make requests to an unintended location. This is, of course, in contrast to CSRF, cross-site request forgery, which is client-side. So this is attempting or trying to make the server, the backend, make a request to an unattended location or unintended location. And then cross-site request forgery is making the client send a request to a location that it should not be sending a request to. In a typical SSRF attack, the attacker might cause the server to make a connection to internal-only services within the organization's infrastructure. In other cases, they may be able to force the server to connect to arbitrary external systems. This could leak sensitive data, such as authorization credentials. I want you to imagine that, I guess in the world of AI, or the era of AI right now, you are making requests to OpenAI, as an example, with your OpenAI token. I want you to imagine that a big company that pays maybe thousands or even hundreds of thousands for AI or something per month, and then it just gets its token or API key leaked. So me, if I could do an SSRF attack, me as a hacker, of course, a bad actor, I would trick the company into making this OpenAI request, but to my server or to my endpoint instead of OpenAI's, with OpenAI token or OpenAI key. Now I have their key and I could just use their key or even leak it, which could cause problems for the company. All right, what is the impact of SSRF? A successful SSRF attack can often result in unauthorized actions or access to data within the organization. This can be in the vulnerable application or on the backend systems that the application can communicate with. In some situations, the SSRF vulnerability might allow an attacker to perform arbitrary command execution, which means we could essentially just take over the server. An SSRF exploit that causes connections to external third-party systems might result in malicious onward attacks. These can appear to originate from the organization hosting the vulnerable application. That means I could essentially, if I could hijack the server that has an SSRF, I could essentially make it attack somewhere else, and it would appear that the attack is originating from the SSRF hacked website. So I could make if I could hack Google, I could make Google attack Microsoft, and then to Microsoft, Google is attacking them. So you can see how bad and entangled this could get. Common SSRF attacks. SSRF attacks often exploit trust relationships to escalate an attack from the vulnerable application and perform unauthorized actions. These trust relationships might exist in relation to the server or in relation to the other backend systems within the same organization. So essentially what you could do is that, or how you could imagine it, is that we have a front-facing website, and then the website is sending requests to a server, and then that server is talking to maybe other servers or internal systems on the same server. But these internal systems, since they are not customer facing or front facing, maybe they will not employ some kind of authorization or authentication, because they think all requests coming to them is coming from this the main server or the front facing server, and they just give no distrust, or they let their guard down. There is no security on that internal server or internal system or internal whatever that you want to call it, application, API, anything. And then we can use this in order, so if we can trick the main server or get an SSRF vulnerability on the main server, we essentially could control or make the other internal systems do stuff that they should not be able to do, or they do not want to do, or maliciously, because they think every request coming from that server is authenticated as 100% trustable. Okay, SSRF attacks against the server. In an SSRF attack against the server, the attacker causes the application to make an HTTP request back to the server that is hosting the application via its loopback network interface. This typically involves supporting a URL with host name like 127.0.0.1, a reserved IP address that points to the loopback adapter, or localhost. So if you've ever like opened the website locally, or like created a website and wanted to view it locally, you know how you type localhost? Localhost or 127.0.0.1 essentially is a way to make the machine talk to itself, essentially. So the browser is sending like a request to the same machine that is running this server. That's why in our SQL video that I just released, which is SQL as fast as possible, we use 127.0.0.1 or localhost in order to connect to the MySQL server that's living on our own machine. For example, imagine a shopping application that lets the user view whether an item is in stock in a particular store. To provide the stock information, the application must query various backend REST APIs. It does this by passing the URL to the relevant backend API endpoint via a front-end HTTP request. When a user views the stock status for an item, their browser makes the following requests. Okay, so we're posting product stock, and then the stock API stock.welike2shop.net port 8080 product stock check, and then product ID is 6, I would assume, and store ID is, yeah, so it's 6 here, and then the store ID is 1. So the %3D here, I think it is an equal, like a URL encoded equal, which is the same here, and then here, so this is equals 6, and then ampersand store ID equals 1. So essentially our stock API is kind of exposed from the front end. This causes the server to make a request to the specified URL, retrieve the stock status, and return this to the user. In this example, an attacker can modify the request to specify a URL local to the server. So then the stock API is just localhost admin. The server fetches the contents of the admin URL and returns it to the user. An attacker can visit the admin URL, but the administrative functionality is normally only accessible to authenticated users. This means an attacker won't see anything of interest. However, if the request to the admin URL came from the local machine, the normal access controls are bypassed. The application grants full access to the administrative functionality because the request appears to originate from a trusted location. So you can see how badly configured this could be, especially that exposing an API like that to the front end. And then we could essentially manipulate this, make it call admin, and then even worse, we could just make it like give us access or make it do functions on the admin panel that we should not be able to do, like deleting users or just getting all users viewing things that are sensitive. Attacks against the server continue. Why do applications behave in this way and implicitly trust requests that come from the local machine? This can arise from various reasons. The access control check might be implemented in a different component than sits in front of the application server. When a connection is made back to the server, the check is bypassed. So essentially, you're just going around the gate. For disaster recovery purposes, the application might allow administrative access without logging in to any user coming from the local machine. This provides a way for an administrator to recover the system if they lose their credentials. This assumes that only a fully trusted user would come directly from the server. I guess that all makes sense. The administrative interface might listen on a different port number to the main application and might not be reachable directly by users. So yeah, maybe that port is not exposed to the public, but is like working internally. But since it is coming from the local machine, you don't need to worry about all of that stuff. These kind of trust relationships, where requests originating from the local machine are handled differently than ordinary requests, often make SSRF into a critical vulnerability. Of course. And finally, oh, we solved this lab already. This lab has a stock feature which fetches data from an internal system. To solve this lab, change the stock check URL to access the admin interface at localhost admin and delete the user Carlos. Since I already solved this, I'll still go with it in this video. But we'll be going through like other labs together, but we'll go through this one as well. While we're here, I'm going to start PortSwigger because we probably want to check the requests that are happening. This is did I say PortSwigger? I meant Burp Suite from PortSwigger. So we're starting up Burp Suite. It is the community edition, so it's completely free. Like feel free to just download it, install it, and follow along if you want. I'm gonna enable my proxy here to Burp. If you don't know how to do that, go to my GitHub, and then I do have write-ups, just basically documenting my cybersecurity journey. I'm gonna leave the link to that repo in the description, and then you can just follow how you can set this up. So we do have Burp Suite here. If I go to proxy and then HTTP history, I can see all the history here. What I'm gonna do is I'm gonna copy the ID from the URL here and then just paste it here. So now I filter my traffic, and this Google is unnecessary. I could just clear the history here. So now all the traffic is gonna appear here will only be coming from this URL. Let's check the fur babies product. Looks fun. And then we can check the stock right here. And then we get 689 units. Now let's look at the product stock URL. So essentially we do have the stock API right here, and it is the exact same that we had in like the read that we've been doing. Let's send this to the repeater. You can send a request to the repeater by selecting it and then clicking Control-R, or right-clicking and then send to repeater. In the repeater, we can essentially just modify and play with the requests. So what we're gonna do is maybe we could use like 127.0.0.1 0.0.1, and then let's do /admin. Let's see what we get. We get a missing parameter. Interesting. So the missing parameter, what could it be? Let's essentially just type HTTP localhost admin. Let's see if we get any different response, and we do. If we click render, we cannot connect to the browser. Okay. And you can essentially see that Carlos, and then we have a delete here, and then we could essentially just like make the request to go to admin delete, and then username equals Carlos. If we do that and then send the request, boom, Carlos has been deleted, and we solved the lab. So you can see how critical this could get if we do get access to something like the admin panel from an external endpoint like this. So congratulations, we just solved our very first SSRF lab. In the next video, we'll be continuing this saga of SSRF, and we'll just be going through the rest of the labs. See you.